Hello everyone, welcome back to Decode. I am Dasumpriya and in this video we are going to learn about space complexity. Space complexity is an important concept in data structures and algorithms because it helps us understand how much memory a program uses. By the end of this video we will clearly understand what the space complexity is, why it is matter and how we analyze it. Space complexity refers to the total amount of memory required by an algorithm to run. This includes memory used by variables, data structures, function calls, and recursion. We usually express space complexity using big O notation just like time complexity. The main goal of space complexity analysis is to design programs that use memory efficiently. Now, let's understand the difference between time complexity and space complexity. Time complexity is measure how fast an algorithm runs. Space complexity measures how much memory an algorithm uses. Sometimes, an algorithm can be very fast but use a lot of memory, while another algorithm may use less memory but take more time. A good algorithm tries to balance both time and space. Space complexity is very important in real-world systems. Many devices like mobile phones, embedded systems, and IoT devices have limited memory. If a program uses too much memory, it can crash or slow down the system. That by understanding space complexity helps us write a scalable and memory efficient program. Programs use different types of memory. Stack memory is used for function calls and local variables. It also used during recursions. Heap memory is used for dynamic data like arrays, objects, and linked lists. Code space stores a program instructions, and static space stores global and static variable. All of these contributes to space complexity. Space complexity is divided into two parts. In first one, input space. Input space is the memory required to store the input data. Second one, auxiliary space. Auxiliary space is extra memory used by the algorithm, such as temporary variables and recursion step. The total space complexity is the sum of the input space and auxiliary space. We use big O notation to represent space complexity. Order 1 means constant space where memory usage does not change with input size. Example, sweeping two variables. Order n means linear space where memory grows with input size. Example, storing an array of n elements. Order n squared represent quadratic space commonly seen in 2D arrays or matrices. Example, adjacency matrix for a graph. Big O helps understand how memory use scales. Different data structures use different amount of memory. Array, order n space, linked list, order n space plus extra memory for pointers. Stack, order n space, queue, order n space, matrix, order n squared space. Choosing the right data structures help reduce memory usage. Recursive algorithms require extra memory because each function calls is stored in the call stack. For example, a recursive factorial function makes multiple calls before returning a result. If the recursion depth is n, the space complexity becomes order n due to stack usage. This is why recursion often uses more memory than iterative solution. To analyze space complexity follows these steps. Step 1. Identify input data size. Step 2. Count extra variable used. Step 3. Check for data structures like arrays or lists. Step 4. Check if recursion is used. Step 5. Add all memory use and express it using big O notation. Let's consider a simple recursive function that calculates the sum of numbers from a to n. Each recursive call adds a new stack frame, so the space complexity is order n. Even though the function uses very few variables, the recursion stack increases memory usage. To summarize, space complexity measures how much memory an algorithm uses. It helps us write efficient programs specifically when memory is limited. Understanding space complexity along with a time complexity makes you a better program. Thank you for watching Decode. Don't forget to like, share and subscribe.
Panda. I got broads in Atlanta. Just took the lean, the family. Credit cards and the scammers. Getting